Okay, well, we got the floor in it now, and that's an inch and a half of just ordinary fire brick. It's what they use in fireplaces and barbecues and outdoor fire pits and things like that. And it's easily replaceable. They're just laying in there. I got them a pretty tight fit. You had to tip them and kind of, slide them in there. And the next step, we're going to drill some 1/4 inch holes in it, about a 1/2 inch deep, not too deep. And I've got some stainless steel 1/4 inch rods. They're going to go in there and act as something where I can put my parts in there and keep them standing up. A lot of times I've got kind of thin parts that need to stand up. So we're going to get some holding rods in there to keep our stuff vertical. But we've got our 10-inch depth there. And those channels in there are for, I'll show you the ceiling. Those channels in there are for my heating element. And that's going to come up next after we get the rods and everything in. All right, but let's get the floor fitted for rods. Okay, so we got some stainless steel pins installed. I drilled not quite through the entire brick, so in that thickness I only came down roughly halfway. So I drilled about a 3/4 inch deep hole. And, this is made to, just lean parts up on, little thin parts, as so. And it gives me 4 places to lean parts on. And still be able to get in there and grab them with pliers, so that's good. And this is some little straight edges I'm working on. These are already hardened. That's a knife edge straight blade there. So that's the kind of stuff I do in here. And I drilled, you see they're kind of wiggly in the holes. I drilled a 5/16 hole for a 1/4 inch rod. I didn't want them to ever get stuck. And I placed them in front of where the element grooves are. So it kind of protects, so parts don't, if they tip over, they're not going to fall into one of the heating elements. So that's how I place those. All right, so the floor is done, and my little rods are removable. So pretty simple. They're 304 stainless rods, and that's it. Okay, let's move on to getting the door mounted. Okay, so we got our oven pretty much assembled mechanically. I did make a new control box because the old box just really was irritating me. Found a lot of hinky stuff inside that box. So this one's a little different. Here, I'll show you inside real quick. I just got one screw in it here. The faceplate comes off with components on it, so we'll have a nice big wire loom coming out to here. And the SSR and the cooling fan will mount down there on the bottom of that box. And you can see those 3 burned looking holes. One's with the thermocouple, and the other 2 down there at the bottom are the entry for the actual element. So they're all going to terminate inside the box. No wires exposed, nothing. Unlike the way the other one was. I came up with a latch. That's just a piece of sheet metal. This is folded over here. That's double layer, 18 gauge, and just a simple angle. Piece of flat bar, 3/4 inch flat bar on a shoulder bolt. And then this little angle is a just kind of a stop. All right. So dead simple latch. Don't know whether I love it yet or not, but there it is. But that's the control box. I didn't shoot any video laying that out. I was just kind of playing with it, and I thought, I kind of want the control to be tilted towards me here. Get my screw back in. All right. I wanted the control tilted, kind of facing up at the operator. I was always kneeling down trying to figure out which button to push, and these things are so darn small anyways, you got to kind of push the buttons with your fingernail. All right. But this gives me plenty of room for the large controller. This is a 6x6 face, so I can do the big digital control if I want to, which I think if I'm gonna make another one and have to buy one of these, I'll go with the bigger controller, the nicer control. They're not a lot of money, but that gives me room to put the SSR and the cooling fan. I'm gonna have openings in the back. I'll have a conduit entry for your cord to come in. I'll have the SSR bolted to that back wall, and then I'll have a big large hole for the cooling fan. and this cabinet will be under negative pressure. So that means the fan is going to be pulling out and drawing air in across the cooling fins of the SSR. SSR is a acronym for solid state relay. It's a relay that can make and break, and it will never burn out. Well, don't ever say never, but it won't burn out. All right, but there we are with that. So let's get into some wiring, and let's get into the element. You know, everyone wanted to know, hey, what is your element any good, or what are you going to do for an element? So I've done some tests, and let's go to the board and talk about it a little bit. Okay, well, let's talk about our resistance wire first. And the experiments I did, I took the original wire, which was 24 feet long, and it had a diameter of 0.046 inches, measured. Now, this doesn't take into account the corrosion, because every time it heats up and cools down, it corrodes and loses its outer shell. So it gets smaller as time progresses. From our original, we were 9.3 ohms. And I put the original element back in the oven and clamped the door on and ran it up. And I wanted to see if I could make temperature. Now, the whole time it's pulling, this setup is pulling 12 amps. So it's pulling 12 amps. That's exactly what the spec is on that little oven. And so I got it back in the big oven, and it ran and ran and ran. And about 45 minutes later, I made 1,400 degrees Fahrenheit. And that's all she had, and there wasn't no more. I did a little more calculation, and I figured that what I needed was 7 ohms. So I did a little bit more math, and I came up with 18 feet of wire. So basically I stretched it out and rewound the coil with 18 feet of wire. Same diameter, same wire, 046. At that point, I was pulling 15.5 amps. And so quite a bit more. And this is, I'm right at, this setup here is about 1,500 watt. 1,500. And with this setup I got here, I'm just a shade over 2,000. 2,000 watts. Now, just that difference in watts, the extra 500 watts, took me to 1,700 with no problems. 1,700 degrees Fahrenheit. The coils heated kind of slowly. They didn't really, just snap up there like I'm used to. So I'm ordering in some wire that size, and I'm going to go. I'm shooting for 7 ohms. So anywhere between like 6.9 and 7.1 ohms across that coil is going to get me my 1,700 degrees, no problem. And I made it there in less than half an hour. You know, it ramped up pretty quick. So that's my calculation. A lot of people were asking how I did my calculation for the resistance wire. So that's a nichrome wire. I don't have a spec on it. I'll throw something down in the description of the wire that I bought. One more thing that I think I should make mention of. The original element that we have here went in an oven. It was 180 cubic inches. That was the total volume of the inside of the oven. Our new element, the modified element, was in the bigger oven. The bigger oven is now 360 cubic inches, so quite a size difference between the two. And that's where we had the need for extra heating capacity, was the extra volume of the oven. So 360 is our new cubic inches in there, and 2,000 watts will do it. The goal of this system is to stay on a 20 amp circuit, 110 volt, bench top, no special wiring. I want an oven less than 100 pounds that you can just pick up, drop on a steel bench top, and plug it into a wall and work it. So, you know, that's the goal of this system. You know, you can buy a much bigger unit, and I see I see these large ovens on the market. You got to wire them for 220. You need a 30 or 40 amp circuit. They pull a ton of electricity, and it doesn't matter how big your part is. You got a little tiny part this big, doesn't matter. You got to heat up that whole oven. You know, and you spend all your money heating the oven just to heat a small part, and it takes forever to heat up, and the whole time it's clocking a bunch of electricity, and there's a gap in what's available out there, and that's why I came up with this little 360 cubic inch oven. All right, that's my story, and I'm sticking to it. All right, now let's get to the wiring. Okay, I'm going to show you the old control here. This is the old control box. And you had a temperature controller here and an on-off switch here. Cooling fan on top, and power cord comes in the back. These two other conduit openings weren't even used. This was a cooling hole. And if I can get this box to slide open. The box is actually nicely made. Too bad it's not made out of stainless. The whole thing is just rusting to heck. Now, 2-wire cord, not grounded, horrible idea. And then they had this the little SSR solid state relay with a heat sink on the back. It bolted in right here. On the flip side, you can see that goes up against an opening. This fan is pulling air out, so it's drawing air in across those cooling fins. So good idea, you know, keeps your SSR nice and cool. And we're going to do something similar on the new box. The few things I hated, they used a 12-volt DC fan. Now, this is the only thing on the whole system that required 12 volts. So they took a wall wart and just kind of took the plug out of it and put a couple wires in, one of those there, and then ran this up to the fan. You know, it was just wired together here, and they just had that sitting in there loosely, which was super stupid. The other thing I saw that I didn't like is all the wires. This box sat well below the oven. The oven was a good 4 inches above this, and they ran all the wiring through this little hole right here, including the ones going out to the element. Now, you'll notice there's not a single fuse on this thing. It's not grounded, and they're running actually the power wiring. This was the power wiring going through this hole. And the elements came out of the bottom of the oven, and they were out in the open. If you were to reach in there, you'd get hit with heat and with electricity both. And then being not grounded, should a wire ever fail, there's no way for this, you know, for it to get back to the ground path. The whole oven could be energized, and if it's sitting on a non-conductive surface, say maybe a wooden bench top or something, and you reached over and touched it, you'd get hit. So I found a lot of things I just hated about this control. First of all, why didn't they use a 110 volt fan and not do this monkey shit? That is horrible there. And then the power wiring going through, a raw opening like that, and exposed wiring, not good. And then the grounding, not a single ground wire on it. There's no way this thing would pass a UL inspection. So those little tabletop ovens can't be UL listed. I was horrified when I got into this control box. But we're going to make it nice and safe. We are going to run a ground to it. We're going to insulate all our wires. Now we're going to use a 110 volt cooling fan instead of the 12 volt. Now we're going to put a nicer probe on it. That's the cheapest possible probe they could buy. And this actually came up through the floor of the oven. It just went through this hole and just stuck up in the bottom of the oven. And it took up your floor space, which is stupid. So I've got a new probe coming, a nice long probe. I need a longer probe now to get in through all that insulation I've added. So I got a new probe coming. This is a new SSR. So we've got an SSR. I've already tested with that. And that's it. I just wanted to show you this old control, and it's just scary when you see what people get away with out there. I mean, for Lord's sakes, they're selling these on Amazon. They're gonna kill somebody someday. All right, enough of a rant. Let's go figure out how we're gonna wire this safely. Okay, I thought I'd show you a cross section of the control. This is the control box that I made. I did not film any video of me making the actual box, but the cover is removable, so the cover plate comes off, so you can access components. I've got a small in the cover. There's a small PID type temp controller and an on-off switch. And I left plenty of room in there so I can change out to the larger PID controller if I want to. But I've got another guy that actually contacted me from the UK, and he's got a very unique PID controller. And I'm not going to give you any more details on that, but it is pretty darn cool. So we've got a cooling fan in the back, opening back there, and it's just held in with a couple of screws. Now this one is going to let the cabinet run under negative pressure, so the air is going out that way. All right, so the cabinet's going to run under negative pressure. The SCR is right down here, and I guess you can see some daylight. There's a heat sink in the back, and there's the fins of the heat sink on the back of the SCR. So under negative pressure, air is going to get pulled in through this opening. It's down low and as far away from the oven as possible, so it'll pull in, hopefully, cool enough air. And the air is going to pull across that heat sink and keep that SCR nice and cool. And then all we got left to put in here is a fuse. You know, you're gonna say, hey man, look at all this open space over, like down here and down here. You know, you got all this open space. Why'd you make such a big box? I'm going to show you in a second. There's my conduit entry. So you're gonna have a cord coming in there. So there's a cord strain relief in there. All right, so that's the backside and a good cross section of the controller. But we've got options. You know, we've got more room to add more stuff. Now let's go over to the oven, and you can see I have been doing some tests already. So we've already brought the oven up to temp, and you can see that pencil line is the outline of the controller or the control box, whatever. This top hole is for a thermocouple. This is where the probe goes into the oven, and I just had it jammed in there, but it'll be sealed, so it's going to go in and get sealed. And then the two bottom ones are where my element comes in. So those openings in the box down low, I've got room for my element to come through and make a connection, and my element to come through and make a connection. And I'll be using porcelain tubes to run through the oven. So we're going to be sealing those openings up too. So basically, with the cabinet under negative pressure, I don't want to be pulling the superheated air out of the oven. You know, I want the oven sealed up against that. But what this does is this encloses all the wiring. The control cabinet goes right up against the oven, and it's cooled, so we're not going to melt a bunch of components. And I think it's going to run good. I'm going to do some tests. I'm going to fire this oven and let it run all night and see if we have a failure. But I don't think heat's going to be an issue. All right, and we did get rid of the 12-volt cooling fan, which was stupid because 110-volt fans are readily available. I don't know why they would go to that trouble to do that other control. But we have no need for a transformer in here. This is all 110-volt base stuff. Alrighty, but now it's time to grab a fuse. I got to run to the electrical supply, get a fuse holder and a fuse, and I'm going to get me a nice heavy cord. You know, I don't want to go chintzy on the cord. The last one had a really tiny cord, and just kind of residential grade. So we're going to heavy duty this thing up, and remember, our element is now pulling 15.5 amps. So, all right. Okay, let's go over the wiring really quick. These are all the components that are currently installed and that were installed on the original oven outside of the little wall wart that was running the fan. Remember, we changed that out to 110 volt. Now we've got a neutral line and a hot line over here, and these are our two incoming. It's essentially our power cord. And the only thing left to add is we want to put in some protection. We've got no protection right now, so we're going to add a 20 amp fuse right on the incoming. Now let's go around and neutral everything up. Everything that needs neutral, we're going to put neutral to it. Off of our neutral line right here, we're going to come in. We're going to hit one side of our fan. It needs neutral to run. We're we're going to come into our temperature controller. It needs 110 volts, so it needs neutral to run. And then we're also going to come into our heating element and hit that. Those are all the things that need neutral. You know, if you've got a lighted control switch that takes a neutral just to burn a light, you'll have to get off to that too. I think mine does have an indicator light in it. So there'll be three, instead of having two poles on the switch, it'll have another terminal to bring in neutral just so it can burn the little LED when you flip the switch on. Okay, but that's kind of optional. All right, let's do the power wiring. We did the neutral in black. No such thing as a white pen, so we did the neutral in black. We're gonna do the hot in red. First and foremost, we're gonna come out straight in. We're gonna hit a 20 amp fuse right away. So basically the whole oven's protected. If a wire goes short anywhere in the thing, bam, fuse goes. And then straight out of the 20 amp switch, we hit our control switch. When this switch is closed, when it does finally close, we're gonna heat up. What are we going to heat up? We're going to heat up our fan. We want our fan to run. We're going to hit our temp controller. So we want our temperature controller to come up. We want to power up 1/2 of the SSR, which inside is essentially just a solid state switch. So you want to picture that as a switch inside the ghost in the machine there. And then out of the SSR, we're going to go straight to our heating element. All right. Now let's, there's some other controls that need to happen. First of all, we need to get input to the temperature controller. So the temperature controller needs to know what the temperature is inside the oven. We're using a K-type probe, and that just gets wired with K-type thermocouple wire. A short section of that to the probe. So that runs to there. So that's 2 wires there. Also, the temperature controller has an output. It's got an SSR output. It's programmable. So there's 2 terminals on there that directly control the SSR. So you got 2 wires that run there. And temperature controller, like I say, is programmable. They're all going to be different, so check your documentation. But the temperature control has an output, tells this switch to open and close. And this is, like I say, this is a solid state relay. You can flutter it and it won't overheat. I mean, it's got heat sinks and everything in it to protect it. It's what an SSR does. It's made for high amperage loads, and it's made to open and close repeatedly. So there's no way the temperature controller alone would handle that type of switching. All right, so that's the whole thing. And then our big thing, our 3rd wire coming in, what are we making? We're gonna ground it. So we're grounding the whole oven. All right, so that'll make it safe. Just those 2 additions between the ground and the fuse, we've made a pretty safe box. So let's go put this into practice and get this thing running. Okay, well, we've got everything wired, and I just used a little bit of the spiral conduit to keep the wires in order. These 2 wires here are what goes out to the actual element. They're just short sections of nickel wire, number 12, nice heavy wire. And without looking it up on the chart, number 12 nickel, the nickel wire. And this is the high temp stuff. I think a number 12 is good for 35, maybe 40 amps. It's quite a bit. So these 2 are going out to the element. One goes straight to the SSR right here. The other one goes to a neutral connection back there in the back of the box. Very secure, and it's going to the incoming power. Fuse installed here. Our power comes straight into the fuse and hits the fuse very first thing, and then goes out there and goes off to the controls, which are out in the cover. And there's your, I'm going to tip these down a little bit. All right, so there's your control switch. You'll notice there's 3 wires here. I had to run a neutral to here because it is a lighted switch. Otherwise it's just a standard switch. And then we powered up our controller here, and then the outgoing to the SSR is just a little belting cable. All right, and it's all enclosed in this. And the goal of this was to be able to install the cover upside down, like I have it here. Just screw it in, be able to work on it, wire it, do whatever you want to do, and then flip over, and everything just installs. Okay, so here it is on the inside with this cover plate installed. You'll notice no wires near the fan. Connections are back in the box away. All we've got out here exposed are our 2 element wires. And then our thermocouple is going to come straight out of this temperature controller. And it's right here in this region, right about where my screwdriver is. So that's the way everything tucks back. And you can see why I offset the SSR out of the way. Just keep it away from the 2 main connections of the elements. So that's the wiring. And we're ready to install this back on the oven. And it's a lot easier to do this here in the vise with some soft jaws than it is to try to do it in the oven. You know, even though I made a nice big box, you still got to get, you know, your big hands in there to work on it. All right, so that's it. All right, and then I'll show you the cover one last time. All right. Well, I was going to point out, I didn't really mention the cord. We are using a big SO cord, number 12, 3 conductor. And you can see in here, we are now grounded. So if something goes bad inside this oven, which the likelihood is very good, you know, running hot elements inside of a metal enclosure, you can get failures and things that go to ground. You know, an element burns in half and jumps over to the case, you know, and maybe your oven is sitting on something non-conductive. At that point, the whole oven is energized. And without a ground path to go back, there's no way to blow this fuse, and there's no way to, or trip a breaker on the wall. You know, if it's sitting there isolated, it's just sitting there energized, waiting for someone to come up and touch it and get electrocuted. So a ground is very important, and fuse protection is very important. And those were neglected on the last oven, and I fixed that. All right. You know what, guys? Our video's running long. I've still got some other stuff to do. We've got an element that's coming in that we need to wind. So I need to show you how to wind an element. I need to show you how to make these connections to your nickel wire, to your nichrome heating element in an orderly fashion where they're not going to fail. We need to fire it up. We need to test it. I need to show off the whole thing. And then we need to talk about making these available to you guys, because there's a very real possibility that could happen. I appreciate you guys watching. I'm sorry this video ran so long. We'll catch you on the next one.